Hello friends, we are going to talking about Robert Kirchhoff's. What is Kirchhoff's law? What is Kirchhoff's current law and voltage law? And their uses and their explanations, some mathematically. So, welcome to anything. My name is Suraj. So let's begin. First is Robert Kirchhoff. He is an outstanding physicist. He was born 1824 in Germany and passed away 1887. He gave us two laws. One is Kirchhoff's current law and another is Kirchhoff's voltage law. Kirchhoff's current law. In any electrical network, the algebraic sum of the current meeting at a point is zero. Its mean we can state it in many different ways. First is the sum of current entering a node must equal the sum of current leaving the node. It means again if we go to the diagram, there is a diagram, and if the current I is enter in a way and the leaving current is I1, I2, I3, the summation of I equals to 0, summation of I in equals to summation of I out on a node. We can say it in this way, that it's mean that I minus I1 minus I2 minus I3 equals to 0, or I equals to I1 plus I2 plus I3. It's mean the entering current equals to leaving current, the incoming current equals to the outgoing current. It is interesting to note that Kirchhoff's current law KCL is based on the law of conservation of charges, which state that the charge must be conserved, so no current can be lost. It is obvious that nothing can cause the amount leaving to be less than the amount entering. This question asks you in this way: state and explain Kirchhoff's current law. Is it based on some physical law? So now let's move on to our second law. The second law is Kirchhoff voltage law or mesh law. The algebraic sum of the product of current and resistance in each of the conductor in any closed path or mesh in a network plus the algebraic sum of the EMF in the path is 0. In other words, summation of IR plus summation of EMF equals to 0. The algebraic sum of the product of current and resistance plus the algebraic sum of the EMF in the path is equals to 0. The total value is equals to 0. In other way, the statement 1 is around any loop in a circuit, the voltage algebraically sum to 0. Statement 2, in any closed loop, the algebraic sum of the EMF equal the algebraic sum of the IR drop. It is noted that the algebraic sum is the sum which take into account the polarity of the voltage drop. You can see the voltage drop in this diagram. The basic of the law is this: if we start from a particular junction and go round the mesh till we come back to the starting point, then we must be at the same potential with which we started. Hence, it means that all the sources of EMF meet on the way must necessarily be equal to the voltage drop in the resistance, every voltage being given its proper sign, plus or minus. Since KVL, Kirchhoff's voltage law, does not depend on the current, applicable even if there is an open in the circuit. So thank you friends. I hope this information. Hit the like button, comment below and subscribe for new video updates. And thanks for watching.